Okay, so what is the best model in the world right now? Is it GPT, Claude, or Gemini? I think that is the wrong question to ask. So there was a recent study in which researchers tested frontier models like Gemini, Claude, and GPT on real-world tasks, the type of tasks that knowledge workers like analysts, lawyers, and consultants do. And they found out that the best frontier model was able to achieve only 24% of those tasks. Now, these are the same models that score above 90% on the benchmarks that everybody argues about online. So either the benchmarks are lying or we are measuring the wrong thing. And I think it's the second one. And that's exactly what I want to talk about in today's video. We need to discuss what actually determines whether an AI agent works or it doesn't. And it's not the model itself. It's what's wrapped around the model that almost nobody talks about today. So let me give you a word that I think is going to define 2026 the way agents define 2025. The word is harness. An agent harness is the infrastructure that wraps around the AI model or LLM. It manages what the AI can see, what tools it can use, and how it recovers from mistakes. It also determines how it tracks what it's doing over a long period of time. A simple analogy will be that think of the model as the engine, and the harness is the car built on top of that engine. And right now, the entire industry is arguing about who has the best engine while nobody is building a car that can actually stay on the road. Now, a couple of good examples of the car around an engine is projects like Codex and Claude Code. Now, both of the models are pretty great underneath, but the thing that actually makes them work is the harness. And this is where most of the companies are going to be spending their real engineering work. OpenAI published a blog post literally called Harness Engineering. Anthropic published a guide on effective harnesses for long-running agents. Manus, which was recently acquired by Meta, is an AI company that went viral earlier this year. They published their context engineering lessons after rebuilding their entire agent framework 5 times in 6 months. Yes, that's 5 times in 6 months. Now, the biggest AI companies in the world are all telling you the same thing right now. The model is not the bottleneck. The harness is, and the data, I think, backs it up. Now, most of the coverage that we see for model releases is still framing this as an AI model or LLM race. So we talk about who has the best benchmarks, who is releasing the latest model. But I think the benchmark story is a spectator sports right now. The thing that matters the most is the infrastructure around your LLM or your agent. And that's what we're going to be looking at in this video. Okay, so let's start with the study that I mentioned in the beginning of the video. So a few weeks ago, a group of researchers published a benchmark called Epic's Agent. Now, what makes this different from other benchmarks is that it tests agents on real professional work. We're not talking about coding puzzles or multiple choice questions. These are the type of tasks that consultants, lawyers, and investment analysts do on a daily basis. Each task takes a human professional about 1 to 2 hours. So they tested every major frontier model. The best one completed the task successfully, I think 24% of the time. We're talking about 1 in 4. Now, after 8 attempts with the same model, the number only climbed to about 40%. Now, here's the part that I think matters the most. The researchers dug into the why agents fail. And the answer wasn't that the models are dumb. The model had all the knowledge they needed. They could reason through the problem. The failures were almost entirely about execution and orchestration. So the agents would get lost after too many steps. They would loop back to approach that they had already failed at, and they would lose track of what they were supposed to be doing in the first place. Now, if you have worked with these agentic systems, you probably have seen similar failure cases in your own work, especially for coding agents. But the interesting thing is that it's not because the model cannot do the work. It's not the model problem. It's mostly about this scaffolding around the model. So let me tell you about what happened at Vercel, because I think this is one of the most counterintuitive stories in the AI right now. Vercel had a text-to-SQL agent. Now here was the flow. You would ask a question, it writes a SQL query. They built it the way most people build agents today. They gave it a bunch of specialized tools, for example, a tool for understanding the database schema, a tool for writing queries, a tool for validation of the results, right? And then a whole bunch of error handling around it. Now it worked about 80% of the time. Then they tried something very radical. They removed 80% of the tools that were available to the agent and give it some very basic capabilities. So in this case, the agent was able to run bash commands, read files, right? We were talking about standard command line tools like grep and cat. These are the type of tools a human would use, right? Now, the results were interesting because the accuracy went from 80% to 100%, and it started using 40% of the tokens. And also, the speed jump was 3.5 times faster. Now, the engineer who built it said that models are getting smarter and context windows are getting larger. So maybe the best agent in architecture is almost no architecture at all. So this example runs completely counter to how most people think about building AI systems or agentic systems on top of these AI models. The instinct is usually to add more tools, add more guardrails and routing logic, because our assumption is that more specialized pipelines is going to help. But in the Vercel study, we found that removing complexity from the harness actually lets the agent to be a lot more effective. And the idea is that these tools were not helping the model, they were getting in the way. This is not an isolated finding, right? We mentioned Manus. They also went almost the exact same direction and had the same realization. So they built their entire agent framework 5 times in 6 months. And here is what they found after all those iterations. Their biggest performance gains did not come from adding features. They came from removing them. They ripped out the complex document retrieval system. They removed fancy routing logic and replaced it with a library of specialized tools with general purpose shell executions. Now here's the more interesting one. They replaced management agents, which were initially used for orchestration and coordination of the agent, with simple structured handoffs. Now this is an idea that OpenAI introduced with their agent framework. But if you think about it, it actually tracks with how these agentic systems or the base models are trained. Usually the base models are trained through RL with very simple tools. But if you start adding more complexity to the tools that it probably hasn't seen before, these models starts doing worse than what you would expect them to do. Now, with this simple harness, they were essentially doing trial and error at the infrastructure level, not the model level. And this is important because it means a better harness dramatically improves your results. Manus also figured out something about memory that I think is really important. Their agent handled tasks that require around 50 separate tool calls on average. And that is a lot of steps. And they found that even with models that technically support huge context, performance degrades as well beyond a certain point. The model doesn't suddenly forgets everything. It's more like the signal gets down by noise. Now, we have seen this. The important instructions from the beginning of the task gets buried under hundreds of intermediate results. So their solution was very simple yet elegant. They started treating the file system as the model external memory. So instead of stuffing everything into the context window, the agent writes important information into a file and reads them when it's needed. This is very simple, very similar to what these coding agents are doing. They usually use markdown files as their memory system now. And we have seen that across the industry, people are gravitating towards these simpler tools and simpler harnesses around the models. Okay, so we are kind of seeing a convergence of ideas here. And I think it reveals something very important about where the industry is heading. So look at the three most successful agent orchestration systems right now. One is Codex from OpenAI. It has a 3-layered system, an orchestrator that plans, the executor that handles individual tasks, and a recovery layer that catches and corrects failures. It's a robust layered harness designed so you can hand it tasks and walk away. So that's one philosophy. The other one is Claude Code, which adopts a very similar approach. You can use a planning agent, but the core is just 4 tools: read a file, write a file, edit a file, and run a bash command. And that's pretty much it. Now, most of the intelligence lives in the model itself in case of Anthropic. That's what we can see from the implementation outputs that the model provides. Now, in this case, the harness is relatively simpler with minimal tools. Extensibility of the system comes through protocols like MCP or the newly introduced skills that the agent can use. And then there is Manus, which arrived at an approach which basically can be described as reduce, offload, isolate. So it actively shrinks the context and uses the file system for memory. It also uses subagents for heavy subagent tasks and bring back the summary. So these are 3 different harness architecture that we see in the wild. Now, all of that converge into the same insight. The harness matters more than the model. And here's the analogy I think make it click. So think about smartphone. In the early days of smartphone, the processor was the whole story. We were talking about faster chips, better phones. But at some point, the processor got fast enough that the difference between them stopped mattering to the users. What started mattering was the operating system. Android versus iOS, the camera software, not the camera sensor. We're talking about an ecosystem and what integrations your device have. So the raw power becomes a commodity and the value migrated to the infrastructure layer that sat on top. That is exactly what is happening in the AI model right now. In the era of agents, harness is the operating system. And the companies and individuals who figure out how to build great harnesses are going to have an advantage that persists even as the underlying models keep changing. OpenClaw is a perfect example of this. Now, there's one more thing I want to address because I think it's the most important architectural principle to take away from all this. Richard Sutton, one of the founders or the creators of reinforcement learnings, wrote a famous essay called The Bitter Lesson. The core argument is that approaches which scales with computational power always end up beating approaches that rely on human engineered domain knowledge. Now, applied to agent harnesses, this means something very specific. As the models get smarter, your harness should be getting simpler, not more complex. If you're adding more hand-coded logic, more specialized routing or custom pipelines with every model upgrade, you're swimming against the current. Simpler harnesses with smarter models beat complex harnesses every single time. Now, built for deletion, every piece of your harness should be something you can remove when the model no longer needs it. So if your infrastructure is getting more complicated while the models improve, you are over-engineering. And that over-engineering is probably why your agent fails. Okay, so what does this all mean for you? If you're a builder, this changes what you should be spending your time on. So I would recommend stop agonizing over models, which models to use. The model is going to change every few months anyways. Start thinking about harness. How does your agent manage context over long tasks? What happens when the model makes a mistake? How does it keep track of what is going on, what it's doing? Does it have access to the file system as an external memory? If you have built an agent that works sometimes but not reliably, I think the problem can be tracked down to one of these 4 areas. So first is context management. The model is losing the plot after too many steps, or it could be tool orchestration, that you have given it way too many tools and is spending more time choosing tools than doing work. Then you want to look at error recovery. So when something goes wrong, the agent tries the same thing again instead of adjusting, or The state persists that the model starts every session from scratch instead of picking up where it left off. If you lead a team, the hiring and the skill development implications are very significant here. The most valuable AI skill right now is not prompt engineering, although I run a channel called Prompt Engineering. It's not model selection, it's harness engineering. Although I would argue that it essentially comes down to how you communicate with your model and how you build tools around it. So the ability to design infrastructure that makes an agent reliable or long-running complex task is what is going to be critical. Now, let's talk about 3 things that you should try. First, try the word cell experiment yourself. If you have built any kind of agent, strip it down, remove the specialized tools that it has access to, give it a bash terminal and see what happens. This might shock how much better it works with less scaffolding. The model is probably smarter than the tool pipeline that you have built for it. Second, I think add a progress file to your agent. So this is kind of the trick that Manus tried, and it's dead simple, right? So have your agent maintain a long running to-do list that it updates every step. It reads the file at the start of each action and writes it to the end. This is what Claude Code also does. Now, third would be learn about some of these new approaches like MCPs, skills, which gives the model different ways of working with external tools. So 2025 was supposed to be the year of agents. And I think for the most part, that did happen. In my opinion, 2026 is going to be the year of harnesses. So you need to be very careful in choosing your harness. If you think Opus is the best coding model at the moment, it behaves very differently in Claude Code compared to Cursor or Antigravity. So choose your harness carefully, whether you're using a coding agent or building one. Anyways, I hope you found this video useful. Thanks for watching. And as always, see you in the next one.